All right, so we're continuing on with the colligative properties of solutions. And the next colligative property that we'll be looking at is that the boiling point of a solution increases when a solid is dissolved in a solvent. All right, so now what does that mean? So that literally means if you dissolve a solid in a liquid, its boiling point increases. And that's why you, for example, boil potatoes in salt water. It also increases the boiling point of water. So it's no longer roughly at like 100 degrees Celsius. It's like at, let's say, 110 degrees Celsius or 105 degrees Celsius. It helps soften the potatoes because you can boil them at a higher temperature. That's a typical, just something that you might know. It also gives salt to the potatoes, but it helps to boil the water, increase the boiling point of the water. So, but why is that? Why does that happen? So when you add a solute to a solvent, we just saw that Raoult's law says the vapor pressure will lower. But what does that mean? And if you recall from your vapor pressure diagrams, I mean the pressure versus temperature diagrams, if you have a curve like that, by lowering the vapor pressure, it means this entire curve shifts downwards. So meaning it literally shifts down. So sorry, my arrow is not completely nicely down. So it means your curve literally shifts down for the liquid because the vapor pressure curve will be lower, so it must shift down. And how do we define boiling point? Well, boiling point is defined at 760 millimeter mercury or 1 atmosphere, right? So wherever that would be on that curve, that's a constant line. And do you notice what happens if you shift this curve down? What happens to where this 760 millimeter mercury curve or line cuts these curves? Do you notice that your temperature shifts to the right? So hence your boiling point went from whatever it was there to a new boiling point, which is to the right, a higher boiling point. So hence that is why if you dissolve something in a liquid, you reduce its vapor pressure, and by reducing its vapor pressure, you inherently increase its boiling point. All right, because you now need more of it to reach before it will reach atmospheric pressure. Okay, so it will lead to a higher boiling point. Now the question is, how does this boiling point vary with solution concentration? So meaning it will probably depend on how much of the solute I dissolve in the liquid, and that is exactly true. So the elevation in boiling point, or the change, you notice it's a change value, it's a delta T. So this tells me by how much does the boiling point increase. All right. And hence it's a delta T value, and therefore we must always remind ourselves that our new boiling point is therefore going to be equal to our old boiling point plus this delta T value that we're going to look at just now. So this delta T value is something that we define or that we calculate using the concentration, the molality of a solution, and something called the molar boiling point elevation constant. So it has units of degrees Celsius per molar, and it's determined experimentally for different solvents, and it has different values. So depending on your solvent, you're going to look it up in a table. So this is look up in a table. Or it will be given to you in a test or exam. All right. And hence, what this basically does, it tells us if you know the concentration, so if you know the concentration of how much of the solid you dissolved, and you know the factor or this proportionality constant, then it tells us by how much the boiling point is going to change. And that's how easy this formula is. The difficulty is, or the thing is, you must just remember that the new boiling point is going to be the old boiling point plus this change, because we only calculate the change in boiling point, meaning by how much it increased. We didn't calculate the new boiling point. It just tells us by how much does the boiling point increase. Okay. Right. So that's basically it. This last part of the sentence, just the value of kBp corresponds to the elevation in boiling point for 1 molar solution. So that's exactly what it means. So meaning these kBp values are determined if you have a 1 molar solution, they determine what is the effect on it, and then these values are defined. So that's what you look up in the table. It's a degree Celsius per molar. So it's for 1 molar. But you, of course, are going to calculate what the concentration actually is, and then hence you will calculate the change in temperature. All right, so that's boiling point. So what do you need to remember? Boiling point increases when you dissolve something in it. All right, so I'll see you in the next video.